Ladies and gentlemen, I hope you had a good break and were able to see some of the demo zone and also get some lunch. For the afternoon session, we have 3 more talks until the next break. Would like to start by introducing our next speaker. His name is Jens Muttschall from Deutsche Telekom. He is the product owner for the 5G campus network and business unit innovation. At RealWear, we get a lot of questions about 5G in relation to our solutions. So Jens, I believe, is an expert, and indeed he spent 14 years of his prior career at Nokia. So I believe he's the guy to ask. So thank you for coming and joining us, Jens, and the floor is yours.
My pleasure to be here. Thank you, Sandra. Thank you. So you set the expectation quite high, I would say here. So, and I wonder how I can raise your attention here after the lunch break and with these really exciting demos, I would say. So yeah, like Sandra introduced here, I'm responsible in so-called campus networks at Deutsche Telekom for connected devices that can be, for instance, ruggedized tablets, ruggedized smartphones, or something else like industrial sensors, industrial automated guided vehicles, or even smart glasses. So I would like to start with the first question, because I saw somebody from Shell here, which is, let's say, also one of our customers here, and I would like to start with customers' problems, which is the, let's say, the starting point of everything here. And whenever I talk to customers, which I did lately, for instance, on this smart production solutions fair at Nuremberg, if I talk about automatic guided vehicles, it's about, for instance, interference, because most of those AGVs are operated over Wi-Fi here, which is a non-licensed spectrum, for instance, so everybody can use it. It's about security, so whenever you talk to the IT department of your company, they always say, oh, is it secure, the network that I build up? Then you have coverage, so that means you are limited when you're using Wi-Fi in terms of coverage, even if you use it outdoor. You're also limited with regards to data processing power, because, for instance, if you have small AGVs, you use a lot of mechanics to carry the weight around here, rather than to compute something to recognize objects. So these are typical problems when you're talking to a manufacturer customers using AGVs. If you take, for instance, smart glasses, we heard something that you have low data rates, for instance, when using Wi-Fi, because video applications are the most exhausting devices with regards to data rates, because you need a lot of, or the high data rates to process video data. So this is one of the typical problems when you have smart glasses, be it AR or be it VR. And of course, the calculation power is also somehow limited, because one of the customer requirement is that the glass is lightweight, it should be slim here, and that is a kind of restriction with it when it comes to data processing power. Then another topic, also, let's say, taken from the oil and gas or chemical industry, is the following: that you have huge plants, and the thing is, if you want to put sensors onto your campus, onto your premises, you have to bridge long distances with long cables here, and that means high costs with regards to material, and also high costs with regards to maintenance. And also the coverage is somehow limited, because you have the huge area you need to bridge here. And in many cases, technologies like Wi-Fi or Bluetooth can't cover the whole area with a single point of access. So these are the typical customer problems I face when I talk to industry players, when I talk to partners, when I talk to customers here. So how can we propose solutions with regards to a network operator, as I'm working for Deutsche Telekom here? And I would like to briefly recap how we came from first generation mobile technology to where we are today, which is 5G, so the fifth generation of mobile technology. And honestly speaking, I like this picture very much. And Sanjay, you mentioned that I worked with Nokia, so some of the pictures I remember by myself here. For instance, everybody, or many of us maybe remember this guy here, starting with mobile connectivity or mobile communication for cars here, somewhere in the 80s here. Then you had these big, let's say, big boxes somewhere located in the trunk here. In the 90s, you might remember that we had this cell phone with the antenna here. So Nokia 8110, this banana phone, very, very famous, maybe known by some of you here. So, and then people started to take the upright position here. But if you, let's say, enter the public transportation right now, you see many people doing like this here. So they stare at their phone and you don't know what they're doing here. Maybe mostly they stream some videos coming from the network somewhere. And today, we have just started with the fifth generation of mobile connectivity, which means that all the things that surround us can be connected. Be it, let's say, a waste bin that you have here, or if you have wind turbines, for instance, if you have cars, even if you have smart glasses, everything is connected. That is the idea behind it. And maybe we are walking again upright here because you can use the smart glass to communicate with machines. Just to give you a glimpse what, or an idea, when we talk about data rates, how long it takes or took to download the latest James Bond movie, which is roughly 6.6 gigabyte of data. If you use the second generation, it took you roughly 2 months here. So that's longer than somebody would have streamed it here today. Even with 3G, where the operators build billions of euros for licenses, it almost took 2 days here. But today, it's about several minutes only. And if we talk about 5G, it's just about seconds to download this 6.6 gigabyte, which is really amazing, I would say. Okay, these are just to get another point of view of this. What is 5G all about? And it's mainly that I would also make you aware that we talk nowadays about new radio, because 5G is more than only the radio technology, which most of you might have in mind. And we have other key performance indicators like data rate that goes up, the latency round trip between or from and to devices goes down to some milliseconds only. And like said, everything is connected, and we're talking about a high density with up to 1 million devices per square kilometer, which can be, for instance, reached when you talk about chemical industry with big plants. You know the big players like BASF or Bayer here, they have square kilometers with 10,000 of devices on their ground, and that might be connected with mobile connectivity. So now going to, let's say, more to the industry-focused area, and maybe one or the other knows this triangle, which has been built by the standardization organization, 3GPP, and you have 3 different things. First of all, as everybody might imagine, you have data rate. So this is called enhanced mobile broadband. So with higher broadbands, we have higher data rates possibilities. The second one is the lower left, that you can collect lots of things, which is called massive IoT, for instance. This is in the lower left here. On the lower right, you have ultra-reliable connectivity, which is, for instance, meant for those people of the oil and gas industry, for instance, where you need to make sure that data can be securely transferred from one device to the other. Their speed is not the issue, but reliability, that the data reaches its address where it should go to. If it goes to smart glasses, we are more in this area, because there you need high data rates to transmit the data here, because we heard it in the very first presentation. If the data rate or if the movement or if the movie, what you see, the picture is interrupted, you get sick somehow, you feel insecure, and this is something we can tackle with this thing here. Okay, what else is 5G? Maybe we first start with 4G here in the content of industrial application here. Today we have the situation that you have a device and you use 4G or LTE as it is today, and then you have the access to the base station here, and it goes to the so-called backbone, which is a data center somewhere, for instance. And in this data center you have the application running, doing some calculation with your data. It can be a video application, for instance. And then you have the way back to the device, and that takes a long time, which is 10 milliseconds here. If we now go to 5G, so the 5th generation of mobile technology, one part of 5G is this edge cloud computing. So that means that what has been formerly operated here somewhere in the backbone in a data center gets now closer to the base station and what we call the edge. So it's near the user. And the benefit of this technique used in 5G is that the latency, the round trip goes down here. And then you feel more comfortable when you're using smart glasses, which actually have the calculation power in the cloud somewhere. Okay, what else is 5G? Today you might have this picture in top of your head. So you imagine you have a network somewhere with this mast, with this pole here, with base stations. You just see this single network, and this is focused on a technology called NB-IoT, which is also somehow part of 5G, and you can operate several things here. But now what is new with 5G is that you build up some so-called slices, some layers here. It's more virtual rather than physical layer here. And it's a dedicated usage of the base station, dedicated, for instance, to application meant for campus applications here. And if you go also one step further, you can, let's say, build up layers and slices for high data rates. That can be smart glasses. Autonomous driving can be another layer. And for instance, if you're operating robots, you need low latency. That could be another slice here. So that also belongs to 5G, this virtual build-up of different slices where you have different or higher quality of service parameters, because in industry you need to ensure that you have the latency. You need to ensure that you have the reliability in your network. Yeah? So that also comes with 5G networks. Okay, some things that might also be of interest for you. So how does it go on, or how will it be deployed here? What will you see in the network itself in the next years here? And this somehow shows you what kind of frequency ranges we are using. You might know that second generation operates at 900 megahertz and 1800 megahertz, somewhere from the top of your head here. And what we do is we have some legacy, what we call legacy frequency, but we can use it also for 5G. We will have new frequencies like 3.x, which have been auctioned, for instance, in Germany in April this year. And it goes up to so-called millimeter waves, which is in that area here, and even higher, 50 gigahertz, for instance, which is actually not licensed, but it's a free license spectrum. The thing is, with the low frequency, you can bridge long distances, you have lower data rates. If you go up, you have higher data rates, but the consequence is that the range is not that high anymore. So that's the drawback you actually have here. And also you have a kind of, or need a line of sight when you transmit data via those frequencies. Okay, so especially campus networks. What we do is actually we bring the mobile network to the campus, which is the premise of a manufacturer, for instance. So our target customers are of the automation industry, process automation, as well as factories in automation and manufacturers. And today, somehow the public network ends here, roughly speaking, at the border of the ground. Actually, it fades out here, that's a consequence. But if you have large premises, like I've shown you, you need to have the connectivity here, and that's what we do. Based on customer request, we can put an IA base station, for instance, just on the premises to extend the public network. And like I have told you, we will build up also slices based on customer requirements. If they want to use, for instance, AGVs, they have requests or requirements with regards to latency, to privacy, and this is built up with those base stations over here. Yeah, that's what I showed you on the premise here. Like I said, the simple version is just to extend the public network. The next step is to use public network with private tunnels. And the ultimate version is to use a separate layer here, which is indicated with the blue. How is it realized? Like I said, we have somewhere the public network, which is connected to the core here. So somewhere in Germany, for instance, we have the cores here where all the operation is done, and it's connected to the cloud here. And that is normally used for making phone calls, for instance, or for sending SMS. But like I said, customers might have some requirements if they operate their AGVs, their robots, that the data to operate such a robot does not leave the premise, and then we operate the whole thing on a local premise, on a local edge server, and do the thing there. Yeah, what are the topics here compared to other networks? For instance, if you have Wi-Fi, or if you have just the public network operated by some other parties, for instance. If you talk about, or if you use Wi-Fi, like I said, it's an unlicensed spectrum and everybody can use it, so there are no limitations. So when using several devices, 10,000 of devices on the same ground, you might run into trouble because they want to use the same channel here. And this is a major advantage of a mobile network. It's really managed so that you can really dedicate the traffic to a certain device. If you have, for instance, or if you use the public network, no one can guarantee that it is there. You have the quality, you have the security. So that's the drawback of the public network. If you have a self-operated network, then you can always run into trouble because you have incompatibilities between the networks. So that is another drawback of if you run the network on a private basis with another company being not a mobile operator. Okay, so coming back to the original question, what were the problems? I hope you remember that picture with the AGVs that I showed you. There we talked about interference. I just explained that we have managed networks here where you can really put up dedicated channels to each and every AGV, for instance. It's secure because you can build up security channels, for instance. You can build up separate layers to keep the security in your network. We can extend the calculation power here because, like I said, you can put the calculation power needed to move through the premises. It can be put to the edge server, for instance, so you can really increase the calculation power. Also, the coverage can be increased, like I said, or like showed, it can be several kilometers if you have the low frequency. So I think there we can put a check mark. If you take, for instance, smart glasses, like I said, we can have really high data rates to transmit video data and to have a good customer experience. Also, we can increase the data rate quite a lot, I would say. Also, there we can put a check mark. And last but not least, about the large campus areas, for instance, if you have a sensor, if you have 10,000 of sensors with an integrated mobile connectivity module, you could put them each and everywhere on the campus ground, and it's much more easier to bridge the distances between the, let's say, the sender and the addressee, so to speak. So now also there we can put a check mark. These are just proposals, of course. Everybody's free to use other alternatives, but this is our proposal how to solve the customer problems I've introduced at the very beginning. Yeah, so thanks very much for listening to what I, let's say, tried to explain to you. Thank you very much for the invitation, and if you have any questions, just let me know. Thanks.
You have a few minutes for some questions. I'm going to start with one question myself, based on some of the customer requests that we get. Of course, a lot of people are looking for a self-contained unit that doesn't require Wi-Fi. And today, the primary use case that we see is this video streaming, this remote mentor, as we call it. So the key thing with the remote mentor is you're using the uplink bandwidth, not the downlink bandwidth. You're sending your video to someone, right? So the uplink is often not talked about very much in mobile networks because it's much slower than the downlink. So what benefit do we get in 5G compared to 4G with uplink?
Oh, that's a very good question. So I feel that it will come. In fact, it is really so. And I have to say that's an issue we are really talking about, how to, let's say, increase the uplink, which is many times lower than the downlink here. And I would say that still needs some time to get that taken, honestly speaking, because it's a legacy problem, I would say, because in past everybody wanted to download movies, and now it's the time that you would like to upload the same thing here, because also in consumer area we have such a thing, because people would like to share videos, and that will evolve over time, I have to say.
Okay, so questions for Jens from the audience here. One here at the front.
John Harris from Panasonic. Just for the audience, really, I just want to get your opinion on what you term to be 5G, whether you expect that mobile devices will include millimeter waves in mobile devices.
So, sorry, say it again. So the millimeter waves.
Yeah. Do you see millimeter wave as mobile or fixed?
That's a good question. It really, I think it's a different application there, because the millimeter waves have, let's say, some physical limits. You need to have line of sight, for instance. You have short ranges. You have the situation that it can't go through tissues, for instance. So I would say it's a different application. It goes more into the direction of not fixed mobile conversion, but the fixed wireless access. So the last, let's say, 10 meters from a base station, which can be in a lamp pole, towards a building. So that could be the application for millimeter waves, because it's about data rates, it's about limitations. You have to tackle weather conditions even here. So that's what I would see from an operator perspective, which is the right application for millimeter waves.
Okay. Of course, millimeter waves goes up towards the ultra-wideband territory as well, where Apple is famously rumored to be doing some future smart glasses that are 3 years away that will be untethered, right? So everyone in our industry, at least, is interested to see what happens there. There's a question here. Yes, go ahead. Ari.
Yeah, I wanted to ask, are we going to need new phones, new devices that can use 5G? Or we're going to stay with our own phones?
Actually, it's a different technology there here. Like I said, we have 5G and 5G new radio. With 5G new radio, you have different frequency, so you have to tune the antennas, and you have to, let's say, adopt the antenna sizes, for instance. You have different transmission technologies or techniques like MIMO technology, so that means multiple input and output directions, so that really requires new antenna, I have to say. And also, like you have seen on the pictures, we have a kind of legacy that we have to use the old frequency first, because there are so many devices in the field here, and that makes it a little bit so that we have new devices there as well. Yeah.
Another question here.
Olivier Racker, IBM. Back to the topic of the antenna, from 4G using 3 to 4 antennas within a device, we're going to switch to 5G with about a dozen or more than 10 antennas within a mobile device. That's still compatible with the ergonomy of the headset, or will you be forced to leverage more real estate like within the helmet or any other part of the worker outfit?
Sorry, do we use still the 4G inside the device?
For 5G, if you want to leverage 5G, can you do that within the small real estate of the headband, or will you be forced to push the antenna location on a headset or any other part of the body?
We will see devices having also antennas for 4G inside. We will have both, actually. From antenna perspective and from technology perspective, we have, for instance, so-called non-standalone and standalone thing here. That means we have a transition from 4G to 5G, still with the fallback to 4G. And for this, you need both antennas inside the smart glass or inside the smartphone.
Maybe I can offer a perspective there as the device manufacturer. We do get 5G questions a lot, and we have been thinking about it, and it isn't in the HMT-1. So the issue is not, I think, the size. I mean, maybe in a consumer device, which has to be very small, it could be the size. But in an industrial device, you have a little bit more space available, maybe a little bit more weight available. The issue is carrier certification. So 4G is already quite fragmented around the world. There are many bands, there are many different sub-technologies even within 4G. Right now we have carrier aggregation, we have LTE-U, we have LAA, we have bands from 700 megahertz to 3.5 gigahertz, and that's just 4G. So along comes 5G. I mean, no two carriers in the world have the same 5G, as far as I can tell. Everyone is different. Everyone has a different flavor because they have a different combination of technologies and bands. So until somebody is able to sell tens of millions of head-mounted devices, how can you make a universal integrated 5G device? Because the certification costs alone will kill you. So I don't know what Qualcomm is announcing with its new chipset XR2 and who really thinks they can ship enough devices to cover that certification cost. But from our perspective, we think that there'll be one more step in between where you attach some kind of module to the device, and that module will be carrier specific. So the main device, you ship that as many as you can, and the module which you attach can be carrier specific. And then we would ask the carriers to help cover the cost for their network of that module. I don't believe you can build a universal 5G head-mounted device integrated in the next generation. Maybe the one after that, but I think this market has to get much larger before that's going to be viable. And we clearly, in our company, would not take on that cost, even though we have some engineering leadership that has done this type of thing before in the 4G world. We would be going to Sierra Wireless or some other module manufacturer like that. They're not the only one that does this pre-certification. It's the only way to make it economically viable. And so I think, I'm not going to pre-announce any products today, but that's the direction I think you should expect to see from the industry, at least from those people that have had to do carrier certification in the past and still live to tell the tale.
But actually, the work, the cooperation, let's put it that way, with vendor, with device manufacturers starts at that point that you talk to the Qualcomms and co of this world here to get it certified. But the thing is, you have this cost, of course, but in the end, you have the benefits I've just shown you. So it's a secure network. It's managed here. Actually, it has some drawbacks with regards to cost. Yeah.
Yeah, it'll come. It just takes market maturity, I think.
Yeah.
Yeah. Any other last question for Jens before we move on?